Thank you for joining us today. And I'd just like to start with a couple of basic questions for people who might not be aware of the paper and the treatment. What exactly is bimodal neuromodulation?
Yeah, and thank you, Nick, for having me on this discussion on our 1082 paper and for British Tinnitus Association. So our company is called Neuromod Devices, and we have the product called Lenire. But of course, in the past, I've been working on bimodal neuromodulation before I came to the company. And just in a broad sense, as I viewed it also in my lab at University of Minnesota, I view bimodal neuromodulation not just sound stimulation and tongue stimulation, which is what is being used for the Lenire device. I view it in a more general sense of just two different kinds of inputs that are modulating or altering the nervous system. Now, you could think of it even broader, sound, for example, that activates the hearing system, and it does modulate or alter the nerve pathways to the brain. And that is, if you really want to get technical, specific, that is neuromodulation as well. But traditionally, people have viewed neuromodulation more with electrical stimulation or an alternative type of energy, whether it's from outside the body, non-invasive, or invasive, like implantable devices that are driving changes in the nervous system. And so then you could think of it in that context as two inputs that are potentially like electrical stimulation or magnetic stimulation modulating the nervous system together. And that the hypothesis, and now data is emerging to support it, that kind of dual input or even multiple inputs can drive greater changes in the brain. And we can get into some of those mechanisms or proposed mechanisms of action, which stems from as far back as Pavlovian conditioning, which we could talk about later.
Okay, so the proposed mode of action for bimodal neuromodulation is the stimulus and changes in the brain.
Exactly, that's the idea. And there's a few levels of complexity there. One, just on a broad level, is exactly how you said it. We want to change the brain patterns. But the other aspect is, the mechanism of action, why it happens, right? Why do those changes happen? And to give just a very more tangible and kind of more well-known example, people are very familiar with Pavlovian conditioning or the Pavlov's dog. And if you think about that, the dog may hear a bell. Surprisingly, the old study, if people read it, the bell was not actually the most common signal that was given. It was other signals, but somehow the bell got associated with that study. But you play a bell and the dog, for obvious reasons, doesn't care about the bell. But if you then pair that bell sound with some synchrony to a reinforcement signal, in this case, it's food, then you can change the brain patterns. And so what happens with the dog situation is that they present the food, the dog salivates, whenever it sees the food. And then what happens is that if you pair the bell when you present the food or close in some, seconds or even tens of seconds, then when you don't present the food and only the bell, the dog will salivate, right? And so what's happened then is that behaviorally something has changed. And then there was seminal studies such as by Dr. Donald Hebb and others showing in the brain, things actually are changing, and the coding patterns for those paired inputs are changing things in the brain. And there's been many more studies over the past 30, 40 years showing that you can do this with sound inputs and body electrical stimulation of the body in different regions to then change the sensitivity of the brain to the sounds. And so that's kind of the second layer. And if you go a little bit more complicated to the third layer, which is where bimodal neuromodulation for tinnitus treatment and where we're pushing towards, in that sense, you could think of it as the tinnitus sound is something that is coded in the brain, behaviorally, obviously, but also physiologically. There's cells in the brain that are coding for that sound. But then what you can think about is, well, you can either eliminate that sound, which is hard to do, but that's one way to think about it. Or you could say, how about you just train your brain to not pay attention or be as sensitive to that tinnitus sound. And, cognitive behavioral therapy, some of these other approaches do that in a more manual cognitive way. But if you could do it almost, what we're trying to do is in a more efficient automatic way, where then we play, if your tinnitus is, for example, 6 kilohertz, just for sake of, explanation here, and we present a 4 kilohertz sound, and we suddenly electrically stimulate your tongue, your brain wonders, why is my tongue being stimulated? 4 kilohertz, geez, something is going on. I better pay attention to this. And so you present that, and that is paired association. We're not giving food, but we are giving tongue stimulation, and we're playing 4 kilohertz. It's not a bell, but it's 4 kilohertz. The brain is now on fire. It's attentive to that 4 kilohertz. And then because of resources in the brain, there's only so much limitation as to your brain being sensitive to everything. And I know this because I have 3 kids, and I assure you, I can't function anything else except my 3 kids' sounds when it's happening. But your brain has limited resources to pay attention to everything. So there is an inherent dilution of its attention to the tinnitus. Then you play a different sound, 8 kilohertz, and then 2 kilohertz, and you play a rich library of sounds. Ultimately, what you're doing is you're making the brain going, oh, I got to pay attention to this. Oh, I got to pay attention to that. And it's the repeated stimulation of this that ultimately then starts to, in a residual long-term way, cause your brain to become more, not, I wouldn't say permanently, because we're not changing things permanently, but more in a long-term way, change its circuitry and coding to become more sensitive to these other sounds, diluting its attention to the tinnitus. So that's a general framework, but it's really grounded in Pavlovian conditioning, paired association, and that's the idea.
So, you mentioned obviously this kind of associations have been known for a while, but you've also been working for quite a while on the Lenire device in various forms. And we talked about, or you talked about the previous study, the TENT-A1 study with David Stockdale, when that was published, and that's actually on our website for if people want to take part in that. So there's quite a background to your work and to the TENT-A2 study. And I know at the time you seemed quite happy with the results of the TENT-A1. So why did you decide to run further studies, and what in particular were you looking for this time?
Sure, very good questions. So a little bit of background for your audience. I know some of them have probably already read the paper, previous one, or observed the last interview with David Stockdale. But just to give some background to context of this next study. In that study, we, keep in mind TENT-A1 and TENT-A2, these two studies, they are exploratory parameter exploration studies. There's a lot of parameter space, and there's limited, if we want to run controlled or systematic and randomized as well as blinded studies in a statistically powered way, there's only so many parameters you can do. We can't test 100 parameters and 5 individuals in each one. We can do a few, and we can do many participants in those arms. And we're talking, hundreds of individuals in each of these studies. So we have to decide what parameters we're going to evaluate. So that's why these two studies are considered parameter exploration, parameter optimization studies. In that first study, we had 3 different stimulation settings. And just for your audience, I know we may talk about this later, and it's always a question that comes up. What do you use for those different treatment arms? And also is there control condition, which I know we want to talk about later. But I will say that the challenge of our approach for designing studies is that the tongue stimulation is super threshold. You can feel it. And the sound stimulation is super threshold. So you need to identify some kind of control that still blinds the individual, because that's the rigor of the study, but somehow is also considered a control. And so what we have decided to do after lots of discussions and challenges and trying to figure out what that control would be is we're running what is called an active control study. And in these active control study, you basically have, if people are more familiar with drug studies, they'd be more like a dose response study where you have different doses and you have to see what effects those have. So in the TENT-A1 study, we have 3 different stimulation settings. They're all bimodal, but you could think of them as different doses, and we had different features in them. And all of them have bimodal stimulation. They have tones and electrical stimulation of the tongue, and they all have some kind of form of background noise that's going on with the tones, and there's just different variations of those. So in that study, just to really get to the point here, is that all 3 stimulation settings, we observed significant improvements within arm. We did see trends between arms, between 2 of the most contrasting stimulation settings. In that study, if people are interested, it's arm 1 and arm 3, PS1 and PS3, respectively, are the stimulation settings. But it wasn't pre-specified. It was more on the long-term scale. And so we could only conclude that there's no significant difference between these stimulation settings. But still, we saw a quite high percentage of responders, about 2/3, if you consider kind of, different ways of assessing clinically important outcomes or benefit. Just rule of thumb was about 2/3, and they can look at the data, the different variations of that. And we also observed that the effects could last 12 months after the treatment had ended for many of the participants. So that was 10A1. Now, from that study, there were a few interesting observations. The first one is we had, as I mentioned, 3 bimodal stimulation settings. And the question then is, why do we see similar benefits or no significant difference between the arms? And we were trying to identify which of those features are contributing to the benefit. And from all the animal research, it appeared that tones are critical, right? This is research from my lab and Dr. Susan Shore's lab and other plasticity research for the last 30 years. Tones are important, or at least narrow stimuli, and pairing it with some body stimulation, right? But the question is broadband noise, that noise component important? I know in my lab, I've used noise paired with tongue or body stimulation. So that's still an interesting question. But in our context of Lenire, is that noise necessary, right? So that was something in 10A2 we want to remove and see how did that affect things, right? The second thing that was interesting was, if you look at our results in that paper, we provide quite a lot of results there. One of the interesting things was that during the treatment, which is 12 weeks, the first 6 weeks, we saw the main drops, so the main improvements. And then there was this kind of a plateau effect that even though we kept providing treatment, there was no additional benefit or minimal benefit, and then it was sustained. The question was, why is that happening, right? And we know plasticity research and also something field called mismatch negativity or kind of novelty detection, the brain tends to adapt to things. And we also know this, when you're listening to things in the background, sometimes they just fade out. So was there some habituation or adaptation? So the idea was, if we change the stimulation settings in the second 6 weeks, can we drive further improvements? So that was something very interesting. And so we designed 10A2 to actually every arm to switch the stimulation parameters in that second phase. So those are 2 interesting questions we want to pursue. And then, of course, the third objective was, this is one large study. Did we get lucky? Are these results encouraging? So we want to repeat this, bimodal in a large scale study. And can we repeat the safety, acceptability, tolerability, and efficacy that we saw in 10A1? So those are the main objectives. And then there were some other components of that study that we looked at different features. We even looked at removing the tongue stimulation and presenting sound only. We looked at complex tones. If it is really getting your attention away, would multiple tones even make your brain even more attentive to other sounds? So things like that is what we looked at.
So your trial was set up this time for 10A2 with 4 different arms to try and answer some of those questions? Exactly.
So we, again, it's challenging to have too many arms to be statistically powered. So we had to make some decisions there. We decided that we wanted to still have some exploratory arms that would give us some information for powering for future studies.
Yeah.
But we also wanted to make sure that we could test some hypotheses. So what we did was we had 4 arms, and if people are interested, obviously see the details. The first 2 arms we had, we're trying to recruit about 80 participants for each of those arms. And then we had smaller sample sizes for arm 3 and 4. So arm 1 and 2 were our main arms that we're testing, and then arm 3 and 4 were exploratory. So arm 1 and arm 2, as I mentioned, arm 1 for the first 6 weeks, we had what we used in 10A1 for arm 1, which was this rich tones, tongue stimulation, synchronized, and background noise. And then in arm two, there's some differences, but the key difference is remove the noise component. And we wanted to see what would happen there, right? It is the noise component really critical? And then in the second half for both of those arms, we changed up the stimulation parameters. Actually, in the arm one, we didn't want to do something that could be perceptible to the participants. So we actually just changed the delays to alter it, almost like what is arm 2 and 10A1, PS2. We changed the delays and some patterns, but it's not perceptible to the individual. So that was a cool design that we did there, that they can't tell that it's changing. And then you have the second stage 2. In the second arm, there was a question of whether noise is still important. And it's not so much about noise or tones, but it's really about pairing something to drive enough changes or attention away. And so in the second stage of arm 2, we actually, instead of playing tones and tongue stimulation, we did noise bursts and tongue stimulation. So that was the 2 arms. But of course, our primary endpoints are focused on the first 6 weeks of that. And then the change in stim is what we're presenting the effects in the 10A2 paper, and everything else we could get into further details, which I could talk about because it's already, I know, complicated.
Yeah. So if we stick with arms 1 and arms 2, because they were really the ones that were sort of maybe the more practical impact, and we're exploring your hypotheses.
Exactly.
Could you briefly explain sort of what you found in the results of these 2 arms of the study?
Exactly. And I wrote out some notes here because there's a lot of numbers here that I do want to get correct. So if you look at arm 1 and arm 2, just, take home message, both of those arms led to significant improvements in both the tinnitus handicap inventory and the tinnitus functional index, right? Those are the 2 outcome measures that we use. They did show significant within-arm improvements during the first 6 weeks. And what we found was that in the second 6 weeks, we obtained additional significant improvements when you compensate for multiple comparisons. And so we actually had about roughly 40 to 50% more improvement. So if you look at the first 6 weeks, we had something like 12.9 points in THI for arm 1. And then for arm 2 for THI, we had something like 11.5 points. And then, so roughly about 12 points during the first 6 weeks. And then during the first 6 weeks, then the second 6 weeks, we went from about 12 points to 19 points in those 2 arms. So that was an additional boost. And in arm 1, as I mentioned, they can't perceive it, the change. In arm 2, they can perceive it. So when you look at that, it's not so much that they perceived it as why this happened. It's basically this changing of the stimulation parameters. That's what's driving these effects to additional improvement, right? So that was encouraging. And then between arms, as you look at the points that I just told you, we did not see significant between arm effect for arm 1 and arm 2. So we can't, the way the study was designed, we can't say that one is better than the other. Or we can't even say that one is inferior to the other, right? Because we didn't do a proper design. All we can say that both are sufficient to drive significant clinical changes. But as to which one's better, we can't make an assessment. We can't say one is superior because we didn't prove that, but we can't also say one is inferior because we didn't do inferiority design, clinical trial design. So those are the key findings. Now, in terms of responder rate, because I think people are quite interested in this, and I didn't break it out, unfortunately. I apologize to each arm 1 and arm 2. But looking at the full cohort, we had, I forgot to mention, 191 enrolled participants. And if you look at all those individuals across all 4 arms, we observed that 95% of participants that were treatment compliant, and obviously came to the visit so we can actually get the data, after the end of treatment, had improvements in their THI. And then 91% of treatment compliant individuals, participants, had some improvement even out to 12 months. Now, I've always had questions come up. Well, what happened to those who dropped out, who weren't treatment compliant, and all those things? So I wanted to give the worst case number of that, which is if you assume that all those individuals who didn't use the device for minimum, or they also didn't come to collect their data, they were all non-responders, which isn't true, but let's just say they are non-responders, then we had over 80% still that had some improvement in THI. Now, I know there's always this other question that comes up. You have this high rate. What does it mean to have some improvement in THI? There, it was any improvement. But some individuals, looking at the paper may wonder, what does that mean clinically? And so there are different ways to use clinically important, minimal clinically important difference criterion such as 7 points for THI, 13 points for TFI. We don't get into that in the paper, but what I think is more powerful is to ask individuals, did you benefit from a treatment? And we did ask that. And what we found was that 70%, I apologize here, let me look at these numbers here. 70% said they benefited, and 88% said that they would recommend the treatment. So that gives you a sense of, maybe the THI scores, if you're just looking at changes, is a higher estimate. But then when you look at more, how many people benefited, they were still more than 2/3. So 70% and 88% recommended.
So do you think that the difference between people, you said 95% showed an improvement in THI, 70% said that they benefited. Do you think that difference in numbers is, what do you think that's down to? Is that just people perhaps expectations, or how they felt about the treatment?
Sure. I do believe that, the way the THI is done, we were presenting different changes in the scores. If you look at how many points you need to be, meaningful, there is the 7 points. And we have done some of the analyses that, I could just share, off, from the paper. But when you do use, like 7 points for THI, we do see it consistent with which is encouraging. I mean, that MCID is encouraging. We do see it consistent with this 70% benefited. So it does line up. And even in our 10A1 study, there's some additional notes that we put online in the Science Journal that is available. We also did that analysis with 7-point THI and what it means compared to what individuals said they benefited. And so it is consistent. So that's where I'd attribute some of that difference. We were trying to stay away from using these criterion because some might say, okay, at different severity levels, 7 points at higher or lower and things like this. So what we did in the paper is we just present all the data points. It's a lot of data, but we do what's called scatter plots. And you can see on the baseline is their, what they came in with. And then on the y-axis, we have after treatment. And you could just see, what their points are and how much they improved. And individuals who are looking at the data can make their own assessment, what they feel is significant or not. And so we wanted to make sure that all that data in a transparent way was available.
Yeah. I mean, you were very transparent with the data, and the study does report quite openly on sort of adverse effects. And I guess if you were just looking at the paper, many people living with tinnitus would be concerned that at some point in the study, 71 out of your 191 people reported an increase in their tinnitus. Could you tell us a little bit more about that, whether that resolved, and how you managed those kind of reports and those people?
Exactly. And I do, this was something that we took seriously. As you know, we have key advisory board individuals like Dr. Berthel Langud, Dr. Deb Hall, and Dr. Sven Van Ness, and several others, Dr. Rich Tyler as well, and myself. We wanted to make sure that we were fully transparent and also include as much we could about what's happening with adverse events. So when you think about adverse events, just to give some numbers here, we had a total of 156 adverse events. And that does sound like a lot, but that's, listing everything that we think could even be remotely related, right? And of those 156, 79 were increases in tinnitus, and you have the right number, 71 participants. There were some individuals that at different stages during treatment, after treatment, before treatment, also had, some increase in tinnitus more than once. Now, again, we know with tinnitus, there are transient effects that happen. There's many things in life that can change things. But we want to, track all of that just to be fully transparent there. So when you look at 79 increase in tinnitus, you have to put a causality, probably related, possibly related, or related. And when you do that analysis, of those 79, only 7 we were sure that they were related. The rest of them were maybe related, possibly related, and we put that in the paper, but we can't rule it out. So we want to be on the more conservative side to say, okay, it's AE, it's potentially related, and just put that all down and list them. But then if you look at, resolved, most of those did resolve in the period of the treatment. And if you also, I'm just trying to look at these numbers here. If you also look, yes, we had 79, but you may have noticed what may look like an inconsistency. We had 70% of individuals saying they benefited and 88% recommending it. So it's showing that we were being a bit maybe more conservative in listing all the adverse events, but just because their increase in tinnitus happened, it doesn't mean they were bothered by it. It just means that there was increase in tinnitus, there was some tracking. Now, there were individuals who were bothered by it, and there were a handful of those, and we talk about that, which ones were more, major or affecting the individuals, and those we did refer them out to. We adjusted some of the things in the protocol and referred them out as well. But those are a small handful that, maybe didn't resolve and then, or lost a follow-up. And there were other interventions that happened afterwards. So that's kind of the idea. And one other comment is, we also showed in that paper that most of those happened during the first 6 weeks of treatment, and we didn't see a significant difference. We actually had an arm 4 where it was sound only, and we had bimodal. And if you look at the adverse events for the sound only, we had the same percentage of, similar percentage of increase in tinnitus in that arm condition as we did for bimodal. So it's not bimodal per se, it's having sound stimulation potentially, if you assume, what are related or not.
Okay, that seems to explain. My next question was, did you think that there is a link between whether people respond or not, if the response group is kind of linked with their tinnitus or type of tinnitus, duration of tinnitus, or the people that found that their tinnitus actually got worse? Do you think there's some kind of link, or is that going to be another sort of study with subtyping people perhaps?
That's a very good question. It's a question that myself, I'm very interested. I know BTA and American Tinnitus Association and also TRI community, a lot of the tinnitus researchers are all interested and excited about that. We did set up the study to have some subtyping. We have some subgroups in our 10A2. We have some subgroups in our 10A1. What we're finding is that it's a challenging question and analysis to do. That there's just so much variations in the individuals, their characteristic demographics, and the results don't come out as clear as we had hoped. So there's still a lot to be learned there. But as we're collecting more and more data, as we mentioned, we have data not only from our large, multiple studies, but also from real world data now. There's multiple clinics in Europe that are collecting data, so over 1,000 individuals. And I do believe, we'll have tens of thousands of individuals, with these devices eventually. And so we're going to be able to really do some nice, bigger data analysis on this and try to get at that question. So very exciting. It's going to be future direction for sure. That's
great. So you mentioned this briefly earlier, that there was some criticism that the 10A1 study, that there wasn't a control group. And again, you chose this time to use an active control. So, scientific skeptics are going to probably find that more difficult to accept that this is a useful treatment because there hasn't been a placebo to compare it with. You did mention some of the practicalities of why you decided to take that approach.
Sure. This is always a challenge with non-invasive neurotechnologies, and there has to be some It's a lot of historical reasons for having this traditional control or sham. But as you know, there's a lot of creativity that comes around designs now. When you think about cognitive behavioral therapy, you have to demonstrate that that's significant. But how do you do that in a blinded, controlled way? And so, they're doing an active control if you think about it, because some of the seminal studies, they actually do cognitive behavioral therapy, and they'll do some other type of counseling, right? So it's kind of a dosage study as well, if you think about it, because they have limitations in what they can actually do. And in a similar way, in psychiatry, psychology, cognitive studies, there's an acceptance that that's okay, because there's an understanding that there's a limitation in how you can design it. I mean, you could do a wait list, right? But people know then that's not a full head-to-head comparison. And so, they may not appreciate that. But then you have cognitive behavioral therapy, and those that, for example, that seminal study by Rima et al., which was, I really appreciate that study. They have kind of two variations of kind of enhanced counseling or cognitive behavioral therapy, comparisons. But that's what you do. Same thing with neuromodulation devices. It's harder because many people come from the drug world, so they do want to see these two types of controls in a clear way. But with neuromodulation, it gets challenging because you have a device. They see the device, they feel the device, they sense the device. And so there's just limitations, unfortunately. And I wish we could do some sham control and you try to use some deceit. But obviously, with Neuromod, Lenire, we're all over the internet now. And if we tell an individual that you're getting sound stimulation, but they don't hear anything, or you're getting tongue stimulation and they don't feel anything, they're going to know they're not getting something, right? So you can't blind the study. So unfortunately, we are limited to, finding active controls. But active controls are actually, in my opinion, the most rigorous type of design, because if you can show significant difference, I mean, you've blinded it, they've gotten some kind of treatment, and you see a dosage response, that's quite powerful, because you always wonder when you give a sham control, do they actually feel it or sense it? Because even with brain stimulation, like TDCS, transcranial direct current stimulation, they'll do a initial pulse and then they'll stop. But when you talk to individuals, they're like, I kind of sense that something's different, right? And then you say, oh, you're still getting the stimulation, but they don't feel it. And are you really blinding them? So these things come up. So with that said, then, for our study, it's true. It is something that's a limitation and a challenge. And the hope was that we would see a significant between-arm difference. Now, we didn't see that. So I totally accept, that there's potential criticisms that, that it's not controlled in a way or showing a difference. But I will say two things that are very interesting for me as a scientist. The first one is that we were able, like in INTENT-A1, to cause the effect, the treatment, and then we took the devices back. And then we had this 12 months of sustained effect. Now, I, as a scientist, have seen studies. It's hard to believe. I'm not saying it can't happen, but it's hard to believe that you get a placebo effect for 12 months out, right? And if we do call that a placebo effect at some point, where do you draw the line that that's placebo and that's really helping and causing a therapeutic benefit? So that is one aspect. The second is, which I think was very interesting to see, was that we changed the stimulation parameters from the first 6 weeks to the second 6 weeks. And as I mentioned in arm 1, individuals can't perceive that change. It's imperceptible. Yet we still saw, an extra, if you look at the points, I said 12 to 19 points in THI, for example, that's 7 points improvement. MCID, if you look at that 7 points, we're getting significant and clinically improvement changes for something they couldn't perceive changed, right? So I think that's quite exciting. So you put all those together in these pieces. I feel good about the study. I know individuals may still want that, holy grail controlled, placebo controlled. But I do think, in the context of neuromodulation, as with cognitive behavioral therapy, there has to be creative alternatives to how you design these controlled studies, right? So hopefully your audience and individuals can understand and see some of the limitations and challenges with doing that, but can appreciate the results in its totality that we published in INTENT-A2.
And I guess another sort of criticism that has been leveled is that even with the real life data that you're getting, it's people who are involved with the development of the Lenire device and with Neuromod. Going forward, are there plans to perhaps have a greater input from individuals who don't have those links, and what are the next plans for Lenire in general?
Yes, a good question. So we did run into that question, and fortunately, we have Lenire available now out in Europe. So there are groups that have already been selling the device and collecting their own data. So we were excited. There's a group, Hanover Medical School in Germany, led by Professor Thomas Lennertz, and they published their paper just earlier this year in a very respectable journal, Brain Stimulation Journal. It's a high impact journal, and they observed quite similar results to what we did in Tent-A1. Now, it wasn't as good, but I would say it was comparable. And considering that they were looking at 6 weeks to 12 weeks versus our traditional 12 weeks, they had consistent responder rates and effect sizes. So that was very encouraging. They had no adverse events in the first 20 patients that they had. So that to us was validation. In a real world independent clinic, we need more data, of course. So as more data comes in and partnerships develop, we're collecting. And more so, what we're interested in is in different clinical processes, right? It's not just that we want how we do it in our study. We want it to see how well it performance happens when you run it in more real world and typical scenarios that they do in their clinics. And so a lot of these is the direction we want to go, because we do know, the clinical trial is very structured and it needs to be for various reasons, but then how that then translates into the community is what we're very interested in.
Excellent. So the next studies really will be these real life data collections. There's not
exactly
sure, and it's been actually great that you've taken the opportunity to share the Tent-A2 study paper with us. The link to the paper is going to be in the conference pack, so that people can go and read it in its entirety. Hubert did a fantastic job trying to explain some of the figures and graphs, but you will be able to see them for yourselves in the paper. So thank you so much, Hubert, for your time. We're going to go over to live questions. I've put my questions about this paper, so we're going to go over to live questions now. So please take advantage of that. And thank you very much again to Hubert.
Thank you so much, and hello everyone. And sorry I can't see everyone in person, but thank you for having me.
That's great. Thank you so much.